This is a quick introduction to the normal curve and probability. So a couple things we need to realize first. You have a normal distribution. This green is an example. And this is where you take multiple measurements of a single thing. So for instance, this could be height or snowfall or whatever. And if you took a finite number, but a lot of measurements, you'd create a histogram. If you took an infinite number of measurements and you had a bin size infinitely small, you would end up with a continuous distribution like this. This says that most of the measurements fall at the mean in the middle, and you have fewer as you get smaller and fewer as you get larger. Many things in nature follow this pattern. And this is the equation for this normal distribution. And then, in order to get determine probabilities, we want to turn it into a standard normal. So we take this equation and we standardize it. And we standardize it by using this z factor. And we set the standard deviation here, sigma. We set that to 1. And to standardize it. And then the mean is set to 0. And we replace what's in the parentheses here with this z value, and we turn into this equation. So this is the standard normal equation. You don't need to worry about either of these equations. All you need to remember is this z equation. So you have to memorize this that's in a box. So you can see we go from measurements, so 10, 10, 10, 30, those are measurements, and we turn them into z values. And as a reminder, standard deviation, a small standard deviation will have a high peak, low standard deviation will have a broad peak. The area under the curve equals 100. Now, if we go to this standard and we start at the mean is 0, the z value is, and then if we go out one standard deviation, we have 34% of the curve. Go plus or minus one standard deviation, we have 68% under the curve. Plus or minus 2 standard deviations, 95%. Plus or minus 3 standard deviations, 99%. So as we go to this page, these are what you have to remember. You have to remember this, and you have to remember plus or minus 1, 2, and 3 standard deviations and their probability. So remember, these are areas. Let me go back here. These are areas under the curve. This is 34%. This is 13%. This is about 2% areas. All right. So let's look at an example of it in use. Here, IQ, you may be familiar with. This is a well-known quantity, and it's been measured a number of times. And if we look at the x values of it, we can, and if we start here is the mean. This is plus 1 standard deviation, plus 2 standard deviation, minus 1, minus 2. So if you look at the x values, well actually let's put in the z values. Z values, and make this a bit larger. z-values. In the center, it's 0. Well, that's 70. Sorry. This is minus 2, minus 1, 0, plus 1. These are standard deviations or z-values, same thing. And then if we put in, we have a mean of 100 and a standard deviation of 15. So this is calculated from all the data. So these are the x values. And at minus 2, that would be a IQ of 70. Minus 1, it would be an IQ of 85. 100 is the mean. Whenever you have a problem, I suggest you set up a curve and on the horizontal axis put down the z and x values, just like I did. Okay, now we can answer a number of questions. So the first question is, what's the percentage of the population that would have an IQ greater than 100? Well, it would be the area to the right of 100. This area, and that is equal to 50%. So the answer to that is 50%. What's the percent that's less than 100? Well, less than 100 is going to be 50% also. What's the percent that's equal to 100? And this is an important point. The percentage of the population where a measurement of IQ is equal to 100 is 0. That's because of what we talked about in class, where no measurement can be exact. That's one reason. The second reason that's so is you're looking at the area of a line, and the area of a line is 0. So what's the percentage of the population that would have an IQ above 115? So what we're looking for is this area. And we have to go backwards a little bit. We know that it's 50% less than the mean. And then we know that this is 34% because of what we memorized up here. So 50, so that's 86. So it's about 16%. The equal sign doesn't matter. If that's the number greater than or equal to 115, the equal sign doesn't matter. Then less than has got to be 84%. Okay, next one is IQ between 70 and 130. So in this case, 70 and 130. I'm trying to do this. So that would be this area. So this one's easy because it's plus or minus 2 standard deviations. So that's 95% what I shaded in. And that means that there's 2.5% less than 70, and there's 2.5% greater than 130. So what's the odds of the IQ being between those? It's 95%. Again, it's important to remember, so the tail, this area right here, would be 2.5%. What's the percentile of an IQ of 85? Well, here's the IQ of 85. The percentile would be, it'd be this area here. So looking at what is to the right of that, is 50% plus 34%. I didn't mean to do this, but it's the 16th percentile. And what's the IQ of the 80th percentile, for example? So let's start with a clean slate to answer that one. So for the 80th percentile, well, I know here that gives me 84% is to the left of that. And so it'd be right around here. And I'm just guesstimating, but you can do this. So that'd be about 80%. So it'd be 50% plus about, it's not quite 34%, so 30%, so I don't know, 25, 30%. So 75, 80, so we'll call it 78. Oh, sorry, not 78. Between 115, so we'll call it about 110. So about 110, and we can check that later. So you should be able to do this in your head. Thanks.